These are the Geometry 8.1 Geometric Mean Notes that do have an additional radicals review in front of it. And again, you should find those documents with Canvas or with the attachments in the emails. Starting off with simplifying radicals, you're going to think factor trees, and you may take out perfect squares or pairs of the same number. Moving quickly into example 1, 63 breaks down into a 9 times 7. The 9 is your perfect square. That becomes a 3 on the outside. Now the 7 has to stay, so your answer is simply 3 root 7. Moving into example 2, 108, I chose to break it down using 4 times 27. You may have done something differently or choose to do something differently moving forward with other questions. For example, it divides by 2 as well, so that would be 2 times 54. That's another approach you can use, but we're all going to get the same answer in the end, hopefully. So 4 times 27 breaks down further into 4. I'm leaving the 4 alone because I know that's a perfect square. 27 becomes 9 times 3. There's another perfect square. The 3 would have to stay. So the 4 becomes a 2 outside, the 9 becomes a 3 outside, the 3 inside has to stay. The 2 times 3 here then becomes 6 root 3. Example 3, 360 is quite easily 36 times 10. Remember, anything that ends in a 0 is a multiplier of 10. 36 is an automatic perfect square that becomes 6 root 10. Example 4 is another question where there are multiple ways to break down these numbers. You could have done 2 and 24. You could have done 3 and 16. You could have done 4 and 12. I chose to do 6 and 8 because I wanted to show you about the pairs of numbers that I talked about earlier. 6 becomes 2 times 3. 8 becomes 2 times 4. The reason I underlined these 2's, this one came from the 6, this one came from the 8, is because, again, talking about that pair factor. So a pair of numbers goes out to become a singular number, 2. This other 2 here is from the 4 because the square root of 4 is 2. So then you have a double 2 outside becomes 4, multiply them back together. That 3 right here trails down and has to stay inside, so 4 root 3. Moving on to multiplying radicals, you're going to multiply the insides, multiply the outsides, sorry for that little typo there, and simplify as needed. Number 5, 2 times 6 on the outside. 2 times 6 is 12. 5 times 8 is 40. The 40 then breaks down. 4 times 10, there's your perfect square. Take out the 4 to become a 2. The 10 we talked about before has to stay because you can't break down a 10. There's no point in doing, you can try it, but it's not going to work for you because 10 is 2 times 5 and neither of those are perfect squares. So 2 times 12 is 24 root 10. Moving on to example 6. 5 times, oh, there's no number there, so it's a 1. That was intentional. If there's no number, it's a 1. 5 times 1 is still 5. 3 times 12 is 36. Square root of 36, that's a perfect square. Ding, ding, ding. Is 6. 5 times 6 is 30. So sometimes these questions won't have radicals in the answer. Sometimes they will, sometimes they won't. It just depends on the numbers that they have within them. Moving into rationalizing the denominator, you're going to multiply the top and the bottom by the same radical component and simplify as needed. Multiply the top and the bottom by the same radical component, simplify as needed. So moving into example 7, you have a 2 on the bottom. You're not allowed to have the roots on the bottom, so that's why we have to get rid of them. So anytime you do that, you want to multiply by itself, because what that's going to do is it's going to create that perfect square or pair, and it just becomes that number. So root 2 times root 2 is just 2. You now have a 4 root 2 on the top. What then has to happen is, you notice 4 divided by 2 is 2. So the answer is 2 root 2. You just simplify as needed. You reduce any time this happens like this, you're going to reduce those. Moving into example 8, same thing. Multiply top and bottom by root 3 to get rid of that square root. Root 3 times root 3 is 3. 15 root 3 on the top. 15 divided by 3 is 5 root 3. Number 9, multiplying top and bottom by root 2. Gives you just a 2 on the bottom. 13 root 2 on the top. You are stuck. You cannot go any further because 13 does not divide by 2, and you certainly do not want to have decimals inside of fractions with these. Moving then into the formality of the geometric mean notes. you have some typewritten notes there. It says the geometric mean between two numbers is the positive square root of their product. To find the geometric mean between A and B, use the proportion. And I should have written something there. That would be A is to X as X is to B. So if you look at example 1, I did that using 4 and 9. 4 is to X as X is to 9. You cross product, cross multiply, X squared equals 36. That is a perfect square, so X is easily and automatically 6. That one wasn't bad. And we get into number 2. Do the same thing. 6 is to X as X is to 15. Your X's are always going to go lower left and upper right. So that creates your X squared, which creates your then need to do the square root of both sides. So the square root of 90 is 9 and 10. The 9 goes out. I kind of skipped that step, hoping you might pick up on that. So I'll scribble that right here real quick. 90 is 9 times 10. See what I'm doing there? The 9 goes out to become 3. So 3 root 10. What you want to start doing moving forward also is, and this is probably the easier part, once you get to this point, go ahead and run that through your calculator, get the decimal answer. Remember that this is approximately equal to, so you may have to account for rounding issues. That's why I'm going to put those there. Those are actually the easier version to get, because if you're doing it in the calculator as it is, if you're doing 6 times 15 in the calculator, just turn your calculator to the side, go one more step and do the square root, get 9.5 with rounding. This version you would have to do by hand, circling around this way to do it by hand and get 3 root 10. But try to start showing both versions moving forward. Give me the radicalized answer and the decimal answer. I'm going to show that with the other questions as well. 8 and 10, 8 is to X as X is to 10. You get 80. So you would, of course, do the square root of 80. And that is actually 16 times 5, so that becomes 4 root 5. Again, easier version would be the 8.9 via calculator. This is by hand. And again, I'll show that intermediate step with the square root of 80, which is the square root of 16 and 5. That's one version of that. So the 16 becomes a 4. This one has radicals in the corners, so that becomes a little more complex. I'll guide you through this one. So 2 root 2 times 3 root 2 is, of course, 6 root 4. 2 times 3 is 6. Root 2 times root 2 is root 4, which is, of course, 2. So 6 times 2 is 12. Then you must continue taking the square root of both sides. There's your square root of 12. Decimal version is 3.5. Again, account for rounding. That's why it's approximately equal to, or by hand, 2 root 3. That would have been 4 times 3 inside. Take the 4 out, becomes a 2. Then we get into these theorems. I'm not going to read those to you. I don't want to bore you. You guys can read those on your own. So with those theorems, let's just get right into the problems. I'll explain how they work. They are a little complex. So if you notice, the line connecting the 90-degree angle to the opposite side breaks that side into parts. I'm not going to say half because obviously it's not half. One's 5, one's 9. But the relationship is that length is equal to the square root of the product of these two numbers. So the square root of 5 times 9, and actually the handwritten version is easier right away. You shouldn't even multiply these together because 9 is your automatic perfect square, so that's 3 root 5. If you want to then go back and revisit the calculator version, that would of course be 45. Square root of 45 is approximately 6.7. So again, let's revisit the idea here. This value is equal to the square root of these two numbers multiplied together. This length is the square root of these two numbers multiplied together. Let's move on with the next example. We also have some issues with the legs. Instead of this segment being asked, the legs are being asked about. Notice what I did here is I added 4 and 8 and got 12 for the whole length. I got the whole hypotenuse of the right triangle. You're going to also need to do that. Anytime you have the two parts and you're asked about legs, make sure you give yourself the answer to the entire hypotenuse. You're going to need that moving forward. Here's how these are solved. What you're going to do is to find this side, is going to be the shorter part connected to it. 4 is connected to x, but 12 is the entire length. So similar to the previous problem, you're going to take the square root of two numbers, but instead of these two numbers, it's these two numbers, the side connected to it and the entire hypotenuse. So I'm going to do the square root of 4 times 12. That's 48. That's easier to do by calculator. By hand is 4 root 3. I'll let you guys figure those out by hand and break those apart. If you're going to y, the similar idea is the side connected to it, 8, and the whole hypotenuse. So the multipliers are 8 and 12 this time. Whatever leg they're asking for, you're going to want to get the side that is connected to it. They're connected right here at the tip. So if they're asking for y, they're looking for you to talk about 8 and the entirety of the hypotenuse, 12. So the pairing there is 8 and 12. That gives you 96. Calculator is approximately 9.8. By hand, 4 root 6. Moving on to, I can turn the page here, get that out of the way. The next example, we're just going to do some practice problems in a continuation of the notes. So they're looking for x. Luckily, that's the connector here. So that would be just 2 and 14. So there's your 2 and 14, 28, 5.3, or 2 root 7. Since they're asking for y, which is a leg, that would be 14 and 16. That would be the relationship there, the relationship with 14 and 16, taking the square root of that product. So let's slide down here. There it is, 14 and 16. Square root is 224, which gives you approximately 15. Notice I did say approximately because that is not a perfect square. 225 is 15. This gave me 14.9 something, so I did feel the need to round it to 15, but I did say approximately equal to. And by hand, 4 root 14. Make sure you're practicing how to do those by hand, even though you're also doing them by calculator. With number 2, we have a lot going on here. We have x and y, those are the sides. They're not asking for this, so I'm not going to use 2 and 4 at any point. If I do x, my pairing would be 4 and 6. For y, my pairing would be 2 and 6. So here you can see the pairing for x, 4 and 6. Take the square root of those two numbers. That's 24. Approximately 4.9. By hand, 2 root 6. Same problem, going back to find y. Again, we said 2 and 6. That's 12. Approximately 3.5. By hand, 2 root 3. Moving down into example 3. If you notice, I have a number written into the problem here that was not there previously. How did I find it? Well, what's 25 minus 6? 19. So you have another part of the picture that wasn't previously provided, which you will probably need, because if you notice now you have x, y, and z to find. So let's start with x. The relationship is going to be between 6 and 19. There it is. Gives you the square root of 114. That doesn't break down. That, believe it or not, does not break down. So that's why I circled it as part of my valid answer set. Square root of 114, or approximately 10.7. To go back and look at y, y is going to be the connection between 6 and 25. The side connected to it, and the entire length, 6 and 25. So there's 6 and 25, 150. By calculator, 12.2. By hand, 5 root 6. Let's go back up to look for z. Z, the connection is 19 and 25. Numbers are getting bigger, but that's all right. No big deal. 19 and 25 is 475. By calculator, approximately 21.8. By hand, 5 root 19. Moving over to example 4. There's a hitch with this one. If you notice, the answer is given. You're missing part of the question. It's not as bad as it seems. Set it up the way you have been. So that distance is now assigned to be a 3. That's equal to the square root of 2nx, 2 times x. So the square root of 2 times x, here's how you continue. You simply square both sides. That'll get rid of your square root. Square both sides, 3 but then becomes 9. Divide by 2, you get 4.5. So x is 4.5. Now you can really quickly and easily find z. 4.5 plus 2, 6.5. You actually saved yourself a lot of work by not having to really worry about how to solve for z. Once you have x, you automatically have z. Then y would be the connection between 2 and 6.5. So there's your connection there. That becomes root 13. Again, that doesn't break down, so you're stuck with that root answer by hand. There's your answer by calculator.